Hi there. My name is Matt Milton. I'm an instructor at Wake Technical Community College in the Air Conditioning, Heating, and Refrigeration program. Today I'm here to talk to you about the sequence of operation for a gas furnace. The sequence of operation is an important tool to know in order to troubleshoot and repair gas furnaces. So the sequence of operation is a 12-step process. The first step in the sequence is what we call a call for heat. That call for heat comes from our thermostat. This thermostat's mounted on the furnace, but typically this is in our conditioned space, maybe in our living room or in our hallway. That thermostat says it's too cold in the room, so we need to make some heat. So it's going to send an electronic signal to our integrated furnace control board down at the bottom, and it will start going through its process. Before anything starts to happen, the integrated furnace control will do what's called a self-check. It's going to check three things. It's going to ensure that there is no flame here. We don't want to have a flame if the gas valve is not open. Second thing it's going to check is going to ensure that our pressure switch is actually open. If our pressure switch was closed, it would not start. And the third thing it's going to look for, it's going to look at our high limit switch to ensure that our furnace is not overheated. Once it's gone through its self-check, what happens almost instantaneously, we're going to energize our inducer fan motor. So we're going to energize the inducer fan motor, which is this motor here. It's going to start to run. As it starts to run, it's going to create that negative pressure draft in our heat exchanger, which will in turn move to step 4, which is prove our draft. So this switch inside of here, this diaphragm will actually close, and that will allow our furnace to move on through its sequence of operation. Fifth step is to energize our hot surface igniter. Again, our hot surface igniter is located in the back behind the burners. It takes somewhere between 15 and 30 seconds for our hot surface igniter to glow bright orange. After that amount of time, our step 6 is going to happen. Our gas valve is going to energize. Once we've energized our gas valve, we're going to look to prove flame. So our flame sensing rod here that we pointed out before is going to be located in the flame, and that will actually close a switch to prove to our integrated furnace controller, our circuit board, that we have a good flame and that we're not spilling gas out into our building. That would be a bad thing. After we've proven our flame, we have what's called a blower delay timing to turn it on. So our indoor blower motor is not going to turn on immediately. We want our heat exchanger and the air inside of our heat exchanger to heat up before we start blowing that air into our house. We don't want to have cold drafts going into our customers and our parents' houses. After that delay timing, we will actually energize our indoor blower motor and blow hot air into the house until our thermostat senses that the room has reached the temperature we've set it at, or our optimum temperature. That's step number 10, our thermostat gets satisfied. At step 10, when our thermostat is satisfied, it's going to do a couple things. It's going to shut off the power to our gas valve. That's going to extinguish our flame. Once our flame is extinguished, we're going to have what's called a post-purge. A post-purge is our inducer fan motor is going to continue to run to get any of the combustion gases out of the heat exchanger and out of our vent system to prepare for a new combustion cycle. And also we're going to have a blower delay timing to turn our blower delay off. Once we turn our furnace off, there's a lot of internal heat inside this furnace that we want to use and make sure we use so we get all our money's worth out of the gas that we're burning. So that blower delay timing will run for a specified amount of time and will turn off at the specified amount of time. So here's our inducer fan motor that we just energized from our thermostat. Once our inducer fan motor starts, it's going to send a signal, or it's going to make pressure and close our pressure switch. It's going to happen almost instantaneously. Once we close our pressure switch, our integrated furnace control board is going to send a signal to our hot surface igniter. This takes about 15 to 20 seconds for it to glow orange. Once it reaches the optimum temperature, our gas valve will energize and we'll have flame. Since we have a good flame, you can see over here our flame rod is in the flame and it's sending a signal back to our control board that we have flame, and our furnace will continue to run and leave our gas valve open. As soon as we prove that flame, it's going to go into our blower delay timing to on. So we have now a time delay somewhere between 30 seconds and a minute before our indoor blower comes on. So now our indoor blower motor is energized, and now it's blowing our hot air through our house via our duct system. And that is the sequence of operation for a integrated furnace control on a gas furnace. Here's a gas valve and manifold that I've removed from a furnace. Again, you can see here our gas valve looks the same, our manifold looks the same, this black J-shaped tube. Mounted in this manifold are what we call spuds. These are these brass plugs in each one of for each burner. Each burner is going to have a spud with it. Drilled into the spud is what we call the orifice. This is where the gas is actually distributed to the burner. Here's a close-up of the burners removed from a furnace. This is a 3-burner assembly. It could be up to 6 or as little as 2. But here you can see the burners themselves. On the end, they kind of look like a jet engine when it burns. Again, the flame typically burns here on the end of the burner, not inside the metal part of the burner. If we have some flame inside the metal part of the burner, these things will deteriorate and melt, and that is an undesirable option. Okay. Here's an example of our hot surface igniter. Our hot surface igniter comes in a lot of different shapes and sizes. This is one example of one. This one is made of silicon carbide, and again, you apply electrical power to it and it will glow a bright orange and super hot. Along with that hot surface igniter, again, our flame proving device is this safety valve, or this safety rod right here. This safety rod basically acts like a switch. Whenever the flame is coming out of the burner, it connects a circuit like a switch and turns the switch on. So if there's no flame, the power goes off. If there's flame, the power will stay on. Here we have our pressure switch and inducer fan motor taken out of the furnace. The pressure switch is used to, again, as a safety switch to ensure that our inducer fan motor is working properly. There's a rubber tube that is hooked to this port, and that senses the pressure that's inside our heat exchanger. Inside of this pressure switch is a rubber diaphragm, so usually somewhere in the middle, and as this fan motor creates a negative pressure or suction inside of the heat exchanger, that will pull this diaphragm similar to sucking on a straw and close these switches that are normally open. So it's normally open when it's not operating. When the fan is operating, the suction will pull that switch closed to prove that we have a proper draft created by our inducer fan motor. You can see our inducer fan motor here is just a small version of a fan. It's got a small motor and a small housing and a very small, what we call squirrel cage blower wheel that is there to create that suction of the flue gases through the furnace. If you're interested in learning more about the air conditioning, heating, refrigeration trade and the air conditioning, heating, refrigeration program here at Wake Tech, look us up online at www.waketech.edu and search for air conditioning, heating, and refrigeration.